Hi, welcome back to LeetCode. So, in this, we will discuss a LeetCode problem, the first and third problem from today's biweekly contest. That is the first problem is the same earliest finish time for land and water rides one, and the third problem is actually same the rides two. So the only difference is that the constant. So here actually you can see the n and m size is 5 into 10 to the power 4, and but in the problem number one, the constant is for the length of n and m can be 100 maximum. Right. So here actually we can actually use the brute force approach, and in the third problem means the second version, we have to use the optimal approach, right? So what is the problem statement? Problem statement is that you are given two categories of theme park attraction. One is the land rides and another is water rides. So land rides, it actually indicate that land start time I, the index I, that means the earliest time the ith land ride can be boarded. Similarly, for the what is the land duration I? So how long the ith land ride lasts? So that means it will start from suppose 10 o'clock at the morning. So it will suppose it will last for the 30 minutes. So it will actually indicate that the starting time is 10 a.m. and the land duration I, it indicates the 30 minutes. Got it? Similarly, for the water ride, it's also similar that the earliest time the jth water ride can be boarded, and the how much time it will actually how long ride the water ride should last. Okay. So a tourist must experience exactly one ride from each category in either order. That means actually want to experience both the actual rides. One is the land rides, and another is the water ride. So it can be any order. So that means it can actually first ride on the land, then actually it can actually ride the actual water also, right? And similar reverse also is possible. First water, then actually land. So a ride may be started at its opening time or any later moment. Suppose we are saying that it will start from 10, and actually it will actually last for 30 minutes. So this means that I can also come at I can actually also start from 11 o'clock also, and it will actually last for 30 minutes. So like it will start only after 10 o'clock. I can start anytime after 10 o'clock, right? From 10 o'clock. Yeah, what is the trying to say? So a ride may be started at its opening time or any later moment. If a ride is started at time t, it finishes at the time t plus duration, because the duration is still constant. If I start suppose from now, so it will last for the t times. Okay, what is actually the duration actually they mentioned? Similarly, for the immediately after finishing one ride, the tourist may board the other, or wait until it opens. Return the earliest possible time at which the tourist can finish both rides. So for this example, that means they are trying to say, um, suppose first I want to ride on the land, then actually I want to ride in the water, because they mentioned that I have to experience both the actually ride from each category one. So means one ride in land, another is ride from the water. Got it? Suppose it actually end at 11 o'clock, so immediately I can start here also 11 to suppose 11:30. Got it? So when actually you are actually it will actually what is the earliest time? That means what is the finish time? It will actually complete both the actually ride, but that means the land ride and the water ride both. So it will actually end at the 11:30. So this is the this time. Suppose it is possible that if actually suppose first I actually ride water, then actually I if actually experience actually land, right? So suppose it actually end actually 10 o'clock it will end. So land actually I can start from 10, and actually it will actually end at 10:30. So what is the finish time? 10:30, right? So we have to actually return the minimum or earliest time it's possible. So this actually the 10:30 we have to return that we can actually finish both the actually right time 10:30. Got it? This is clear. Now go to the example one. So how is it getting the output 9? Suppose they mention that so there are two categories possible. One is the land start and the duration. Similarly for water ride start and the duration. So length will start from, there are two event will happen. One is the start from 2, another is start from 8. Start from 2, another is start from 8. What is the duration for that? Respectively, one is 4 and 1. 4, duration is 4, second one is 1. Similarly, there is water event also, water ride. So there is only one event in the from the water ride. So it start at time 6 and the duration is 3. Clear? So it will start from 6 and duration is 3. So how can you actually think that we can actually solve the problem? So that means we have to express both the actually right from each category. That means one from water right and one from the land right. So that means, so order can be anything, first water then land. Similarly, I can complete first land then water. Okay, suppose case 1 is first I will try to complete water, then I try to experience the land, right? Okay, so water right, it will start from 6, only one actually water right actually present, so it will start at 6, so it will finish at 9, correct? So this is actually two time for water. Then now I want to experience the land, right? So land I can actually ride here also, I can ride here also. So which actually event I can actually use? So can actually ride in this first event? It's possible because we can actually start time is 2. So they mentioned that I can actually ride any event if the start time is greater than or equal to the current time. Sorry, less than or equal to the current time. So that means I can start from 2, 3, 4 any time. I can actually ride to this event. Clear? Similarly for here also I can actually start ride 8, 9, 10. Clear? In this time I can start. So if I actually choose the first event, so when actually I can start only in 9 and it will actually last for 4 minutes. So ultimately it will actually end at 13. Clear? So if I actually choose this event, first is water this and then this, so it will actually take 13 minutes or 13 minutes suppose. Now there is another option, this option also I can choose also this event, this land ride. So that means the water will end at 9, so it will actually start at, there is no what time because this already started at time 8, we are actually reached at time 9, so I can start from immediately, so there is no what time. So how much time it will take? It will actually take 9 plus 1, so it will actually end at the time 10. Got it? So if I want to follow this order, that first I want to experience water ride, then actually I want to experience land ride, so it will actually take actually minimum time actually is 10. Clear? Now if I want to experience first land ride, then actually I want to experience water ride, so or actually I can start there are two options to complete the land ride. So one is the first event and this is the second event. So if I choose the first event, so it will start from 2 and it will actually take 4 minutes, so it will end at the time 6. Clear? This is for land. Now I have to do one water. So water it will start at 6 and the duration is 3. So I will reach the that event at the time 6. So I can start immediately. So there is no wait time. So it will start at 6 and the duration is 3 minutes. So it will take you 9 minutes to complete both the events. Clear? Now there is another option to of the land ride. So that actually 8. And how much time it will take? First finish the land ride. So it will take 1 minute. So it will actually end at the time 9. Okay. Now I want to ride a water ride. So water ride, there is only one option. So whatever time it will take, it will start at 6 and it will take actually 3 minutes. But I will reach at the time 9. So it will start immediately at time 9. So that means it will take actually 9 plus 3. So that means 12. So for this sequence, first land, then water, right? So what is the minimum time? It will take 9. Okay, because there are two options, 9 and 12 for land and water, and for water then land there are two options. One will take 13 minutes, another will take 10 minutes. Clear? So out of all this, what is the minimum time? Minimum time it is 9. Clear? So our answer will be 9. Clear? So that's why you just see what is the actual time output is 9. Clear? So what is the brute force approach here? Actually you can think. So whatever actually I have explained, that will be the actual brute force approach. How? So I will explore all the combination, because I know that one actually I can do land then water, another actually I can do water and land. So this can be any event actually I can actually do that with any event, right? Suppose there are actually two options. Suppose in the land ride there are three events are possible: x1, x2, and x3. Similarly, for the water ride there are actually four events are present: y1, y2, y3, and y4. Got it? Now, what actually I can do? This actually all actually land, and this is all actually water. So I will actually try to complete x1, then y1, means this event, clear? Then, so this actually first land, then water, and this will be for sequence if I want to explore water to land. So this will be y1 to x1. Got it? Similarly, I can explore x1 with y2, right? First I will explore the land x1, then actually I want to explore uh, water right y2. Similarly, reverse is also possible, because I can actually experience the first water ride, then actually land ride. So it will be y2 comma x1. Similarly, it will be x1, then actually I can explore the y3. Similarly, y3 with x1. Got it? In this way I can explore. So you just see what actually you are trying to explore only. So there are two pointer I and j. I is pointing at the land and j is pointing in the water. So with each I, that means with x, with x1, I am actually exploring y1, y2, y3, y4. But similarly for x2, I will explore y1, y2, y3, y4, because all these actual combinations are possible. Clear? Similarly for x3 also, I will explore y1, y2, y3, y4. Clear? So this is clear how you are getting the output, like how you are trying to implement the brute force approach. So what is the time velocity for this? So I know actually understood the actually approach. So I will take the two for loop. One is for I, another for j. So for each I, with each j, actually I will check if I first complete the L, then what L means the land right, then actually I try to complete the water right. Similarly, I will try to explore what the time it will take to explore the first water right, then land right. Clear? So what is the time velocity it will take? It will take big of n square. Clear? This approach clear? Now go to the code for the question number 1. So just see. So I have written an answer that actually return the minimum time it will take to experience both the actual event from each category. So answer I will start from infinity. So int max. Now there are two for loop. One is for the pointing at the land start or the land event. Another is pointing at the water event. So what actually I can do? First, there are two options are possible. First, complete the land right, then actually complete the water right. Another is possible the first water right, then the land right. Correct. So that's why you just see that there are two for loop, and I have already explained why actually I actually nested for loop, because all possible actually combinations are possible. Like for with x1, I have to explore all the possible water right? Similarly for x2, I will explore again all the water right, because it may possible that I can actually get the best answer. So that's why I have to explore all the combination. Now first try to complete I means the land, then land right, then complete the water right. Then what will time it will take? So first of all, how much time it will take to complete the land ride? So it will, I know, because this is the first event, land ride is the first event, so there is no wait time. Whatever the start time, I can start immediately. So this is the start time for the land event, and the duration for this current event. So it will actually finish time will be f1. So that means whatever the actually time actually I have, that means for this, suppose I am starting this event. So what is the finish time for the this first land ride? So it will take 2 plus 4. It will actually end at the time 6. Okay. Now suppose I want to experience a water ride. Suppose this is 6 is this event is the water ride I want to experience. So when actually I can start? I can start only, like it will be possible that I actually complete the first event at the time 10, but our start time is of the water event is suppose 6. So I can start only at 10. So that's why I have to take the maximum value. Whatever the start time, water right start event time and what is the finish time. So out of this I have to take the maximum value, because suppose this is a situation, our start time is 10 and the previous finish time is suppose 6, then I can start only when I can start only at time 10. I have to wait for 4 minutes, clear. But suppose finish time is, so there are two options. Finish time is actually is 10, but the event I can start actually 6. So do I need to wait? Not, but I can start only at 10. Clear? Actually, it's only at 10 because I am finishing at the previous event will finish at the time 10. For the current event, the start time is 6. So I can only start at time 10. So that's why I have to take the maximum of whatever start time. It may be possible that I have finished the previous ride before that. So that time I have to wait for that time, whatever time actually I have to wait. So that will be even anywhere it will be counted. So because I can only start at 10 and 10 plus t, it will be actually the finish time. So that's why I have to take the max of finish time of the previous approach and the what is the starting time. That will be the current starting time. Got it? So that's why I'll take what is the maximum value of the start time of the current water ride event and the previous or the finish time of the land ride. Got it? And duration will be constant, same. Anyway, it will be actually added. So I will actually add that. Got it? And what is the answer for that? I have to actually check out the minimum time, because I have return the minimum finish time. So that's why I have to compare with the answer with the current finish time, because this is the ultimate finish time. Because after in this F2, I can say that within this F2 time, I can actually experience both the rides, one from water ride, one from the land ride. Got it? So this is for when actually I try to explore the first land ride, then water ride. Similarly, this will be also reverse is also possible. First water ride, then land ride. So first of all, I will actually complete the water ride. So how much time? When actually it will finish? It will finish the start time plus the duration time. Okay. So in this F1, actually I know that what is the finish time for the water ride. Now I have to explore the land ride. So when actually I can start the current land ride. So I can start only at what is the maximum time. So what is the previous finish time F1 and the current start time. So I have to wait if it is our I have already finished the previous event before starting of the current event. So I have to wait that time. So that's why I have to take the maximum out of this, and I will add the duration. Got it? And similarly, actually I'll compare with the answer. What is the finish time for this in this sequence? First water, then land. So I'll compare with the answer, and ultimately after this for loop, I actually explore all the combination. Got it? And return the ultimate answer, what actually I actually have. So this will take 2 for loop, big of n square. So actually you can just see that actually n size is 10, 100. So it will take actually 10 to the 4. But for the third problem, what is the length of n and m? So this is actually 5 into 10 to the 4. So this actually in the worst case, the time was really 5 into 10 to the 4 into 5 into 10 to the 4. So this is 25 into 10 to the power 8. That's actually greater than 10 to the power 8. So it will actually surely it will give us TLE. So I have to think actually some optimal approach. How can I optimize this? So in the brute force cycle, what we are trying to do. So I will actually for each length, I actually exploring all the water event, right? Got it? Similarly for x2, I will exploring all the water event. So that's why it usually take the big of n square. But if I actually suppose x1 plus y1. So in this it will take time x1 plus y1. Similarly for x1 plus y2. What is the finish time? I am trying to explore just. Similarly, this will be x2 plus y1. Then will be x2 plus y2, right? Now, what actually I have to ultimately do? So if I actually somehow know that what is actually minimum x1, minimum start time actually I can do, then actually it will take constant time, constant, not constant time, big of n. That means I have already fixed that this is our start time, or start time of what, land. Okay, start time of land, right? So if I actually fix that, then actually I can actually explore all the with all the y1, y2, y3, right? Similar way, if I actually fix that, what is the start time of water, right? So then actually I can explore with all the x1, x2, that means all the actual land, right? x3, got it? So here actually I have fixed the x, here actually I have fixed the y. Now why actually I'm saying that I can actually optimize here? That means let's just see the first example again. So 2, 8, 4, 1, but and another is 6 and 3. So there's another option for the water event 10, 2. Okay, suppose I want to know that I know the sequence that I can actually finish the problem with. First actually I can actually experience the land ride, then actually I can actually experience the water ride. Similar way actually I can explore the water ride first, then actually I can explore the land ride. So when actually I should actually get the best start time for the land ride. So which actually give us the, because ultimately we are trying to explore that f1 means the start time of length of I plus duration of I. Then actually trying to explore f2 of maximum of f1 and water ride j, correct? Then duration is constant j. So ultimately you are trying to maximize this value, but our target is 2, because this duration will be anyway constant. So somehow our target is to minimize this. So how much I can minimize? So this will be constant, this water j, this will be constant, water j. I can actually only optimize this f1. So what is actually the best approach? So I will also try to finish fast. This f1 should be as small as possible. Try to finish the first event as fast as possible. Now during the f2, so I can only explore f1 comma current start time of j. Clear? So that's why I can actually decrease the effect of the influence of finish time for the first event or the previous event. That means what I'm trying to say, suppose we actually have 2, 8, 4, 1. So if I actually accomplish this first event at the first, so how much time when actually it will end? It will at the end time 6. Similarly, when actually it will end at the time 9. So when actually we should actually choose the best. So I can actually get the best answer if actually accomplish this event first. Got it? Similarly for the water ride, so it will take 6 and duration is 3. So how much time it will take? 6 plus 3, 9. So it will finish at the 9. So when I trying to first, this actually for land. So first I try to accomplish the land, then actually I try to accomplish the water. So what actually I should actually choose as the start as the land event. So this should be the best event to choose, because this actually it actually complete at the first. So 6. So it will actually complete at the 6. Now water event, it will actually start immediately because the starting time is 6. So it can actually start immediately. So how actually it will end? 6 plus 3. So 9. Got it? How actually get the best answer? So this is the total time if actually follow this order: first land ride, then water ride. Okay. Suppose now it may possible that I actually get the best answer if actually follow the order, that first water ride, then land ride. So if actually follow the water ride first, then what is the best time? I can actually complete one event. So that will be at the time 9. Got it? So it will complete at the time 9. So then actually I have to explore all the possible length, because it may possible that, because this is not constant, because it may possible that I can get the, in different combination actually I can get the best answer, because this start time will be changed, because here actually it will finish at the time 9. So time 9 it will finish. So 9 plus, it will start at the time 9 second event, and the duration it will take 1. So it will be end at the time 10. Got it? It will at the time 10. And for this event, if I actually finish the first event, so it will take 4. 9 plus 4, it will take 13. So best answer is 10. So that's why for this, I will first fix the water. What is the best water ride actually I can actually do. Then actually I have to explore all the possible land ride. So that's why I will first finish this for loop that actually I am trying to do. So this will be now fixed. So this will take big of y1, because I have already fixed the best starting land ride. Then actually I will explore that with this best land ride, what is the best with which water ride actually I can get the best answer, best time. Got it? So that's why it will take big of n. Got it? How to optimize this? So now go to code. So first of all, I have to know what is the best water ride and what is the best land ride. So which event actually I will call this is the best. So that actually finish first. Like what is the start time and plus with the duration, because it may possible that start time is actually 10 and it will take actually 1 minute. So it will end at the time 11. But it may possible that it will start at 2, but the duration is 100. So it will end at the 102 time. So this will be our best time. Got it? Because this actually it may actually give us the best answer. So that's why I will take this. And why actually I am storing the ultimate time, that actually you clear, because it actually depending on the how much time it will take complete the finish. So this actually ultimate time, not you just don't see the what is the start time, because it is possible the duration is more. So then actually it may actually give us the post answer, not the optimal answer. Got it? So this actually the that's why I have to take the total time it will take to complete. So that's why in the priority queue you can also take a variable also to take what is the best land ride and what is the best water ride. Got it? Here I have used the priority queue. You can also optimize this with using two variable also. Just compare with the what is the till now actually what is the best answer I have, and what is the current best what is the land start current time start time, and what is the duration. So I know what is the total finish time. Got it? I can actually compare that, but here actually I have inserted into the priority queue. Similarly for all the water rides also, I actually created another priority queue for the water ride. Got it? And store this for the finish time. Got it? Total finish time. Now I have to return the answer total time. So what actually I can do? First I know what is the sequence, because I can actually complete the first land ride, then water ride. So if I actually fix the land ride first, then I can explore with that best land ride what is the with which water ride I can actually get the best answer. So that's why. So what is the land ride will be the best? So that will be present at the top, or you already have, if you have taken the variable. So then actually you will store the total finish time, minimum finish time. So here also I have taken a minimum heap, so that's okay. So it will return the what is the best finish time for the land ride. Got it? Now with that best finish time, I have to explore all the water ride actually I can do. Then I have to check that with which water ride I actually get the best answer. So that's why I'll actually explore all the n2 is the number of water rides. So each water ride I have to check that what is actually the finish time, ultimate finish time, because land plus water, ultimate finish time actually we need. So that's why I'll take similar actually I'll take the maximum value of the start time and thus the finish time of the land ride. Now add the current duration. So this actually gives the ultimate finish time for this like the base start land ride and the current water ride. What is the best finish time? So ultimately what is the finish time? I will also compare with the answer. Got it? Similar way, I have to know the with the order of the water first, then a land ride. So best water ride will be stored at the top of the mean heap, because it will give the minimum time I can finish one water ride. Similarly, actually you can take another variable also. I have already explained. So this actually give the what is the finish time for the water ride, best finish time for the water ride. Now with that best finish or water ride, actually I have to try to combine all the actually land ride, then check that what is actually the ultimate finish time. So that's why I'll actually explore all the 0 to n minus 1, n1 minus 1. N1 is the number of land ride. So similar way, what is the ultimate finish time? So what is actually the previous finish time? That actually I will get from here. I have already fixed that. And what is the current start time? Because I have to take the maximum out of this. And the duration will be constant, any utility will be added. So and after that I will know what is the ultimate finish time and compare this with the answer actually I have, and ultimately return the answer. Got the logic? That how actually I have optimized that from n squared to n, because ultimately we are trying to, previously in the brute force we were trying to combine all the combination with each length, for each length with all the water, right? Similarly, if I actually fix that, what is the best length start, then actually I will get the ultimate best answer. It may actually give us the best answer. So that's why just fix the best land ride, and similarly fix the best water ride. Then actually with this I have already fixed the best water ride. I know when actually it will end. It will be completed at the best time, and with that actually combine with all the land ride. Clear? I hope this is actually clear. And if you have any doubt, you will comment on that. And if you found this video useful, please like the video. And if you have any suggestion, you will comment on that. And if you are not yet subscribed, please subscribe channel. Thank you. Bye bye.